Photography, the art of capturing a moment and keeping it that way forever. Behind every art, however, is a science, and in particular, chemistry. I am Dr. Ryan Westervolt, and today we will be talking about that art, that science, that beauty. Take a moment to set your expectations for this project. Done? Now take a moment to anticipate my shattering of them as you witness the sole greatest achievement of human creativity through a chemistry project the world has ever seen. We'll cover some basic topics like the history of photography, how cameras work and how they have worked, picture development, along with a scientific thesis through means of a simple lab. Then, as we go forward, witness pictures taken by yours truly and have their components dictated to your listening ears, materials and buildings, clothes, the very essence of life. Stick around for the conclusion at the end with a glossary and bibliography for those daring enough to check them. Buckle your seatbelts, your pants, and your socks, because if you don't, they'll be knocked off by the end of this video. No. Short movie presentation. The first camera, named the Camera Obscura, was created near the year 1000 AD by the scientist now known as Alhazen. The funny thing, it wasn't even a real camera. Talk about an epic prank. No, it was just a pinhole in a wall able to project images comprised of varying shadow colors based on light blockage on whatever was outside the pinhole. In 1827, however, Joseph Nicephore, I wonder just how nice, took a photograph. However, it was more of a light-hardened image than one that utilized exposure. By placing a pewter plate with a special substance coated on, he was able to create a working camera that enabled him to capture an image through hardened plates, and this came after almost a decade of hard work. How he found out all those chemicals eludes me, because his patience must have been incredible. The picture, once ever so slightly more vivid than it is now, was always dingy, but eventually faded so that the image was hard to see. What a shame, considering it was only his life's work. The next great scientific breakthrough, how great was it considering I have to do this project because of these guys, was from Louis Daguerre. He worked at around the same time as Nicephore and ironically outdid him by both shortening exposure time and making pictures that didn't fade. Nicephore did do it first, however, securing his bragging rights. Despite this, Daguerre outlived dear old Joseph and created the daguerreotype, which has set the standard for all photography after it. This only added a few extra steps to cameras they had both made, and was made in collaboration with the late Nicephore and later, his son. Silver chloride was the secret ingredient to making the photos stay pristine enough where people could actually take a few guesses as to what they were of. Very shortly after, Daguerre and Nicephore II sold the rights of this wonderful machine to the government, progressing the science of photography. Following these achievements, with camera prototypes and additions now in place, the next new tech needed to be with the film and pictures. This led to Henry Talbot's development of negative in 1841, paper with sensitive chemicals on it where light would burn an image into it based on short times of exposure. This led to the places on the photo with the most light to be the darkest on the paper, though when these negatives were developed, they were the opposite, or negative of that, and flipped the shading. Soon after, to one-up Talbot in 1851, Frederick Scoff Archer invented wet plate negatives that utilized wet plate development technology never seen before by the human eye, or again because we're not as primitive as he was. A simple invention in 1889 was the flexible film roll by George Eastman, allowing for film to be better utilized inside of cameras. As chemicals progressed and the lens worked better to capture light, Kodachrome, or color photography, for those who didn't know that, was invented in the 1930s by Eastman Kodak, which was utilized largely in the media for decades. Polaroid cameras were invented in the 60s, followed by the new digital age. I think that's supposed to say age. The new digital age, led by camera company Canon, who is still doing well today, thriving as the best company, who would have thought, with their new cameras of electronics. These revolutionized picture quality and light quality. Lens developments also came, making photography widely used in the modern hip cool age. This takes us to now, where the last few decades have been slow but steady improvements to quality and lens. Mostly technological stuff, to be honest, no big breakthroughs. This concludes the epic chapter in this side of photography's history, but who knows what's to come? What's out in the dark? Old cameras. We love 'em, we hate 'em, we love to hate them, we hate to love them. They're tacky, slow, but somehow majestic. 35mm film, that's the one, the right one, that one that we used and we're focusing on. This camera type, like all others, has three main parts or sections: the optical section, housing the glass, viewer, mirrors, and lens that allow the light to form in the picture; the mechanical section that includes all of the technology and is really just the camera's body, and the chemical section within this body housing the film and chemicals on it. The lens consists of the mirror, angled curved glass that make it up, and this shutter. The shutter is the thing that makes the clicky noise when your camera takes a picture, because it moves really fast open and close to burn the picture in without ruining the film. The body and film work together to get the film into place and move the shutter in order for it to produce a picture successfully. All three components move in complete harmony, and if they did not, pictures would not work. They just would not. The main body of a camera contains a viewfinder for seeing through the camera, several tools to adjust the lens to let more or less light in, based on your surroundings, a battery to power the camera's flash and if it has electronic components, a film slot with film in it, the mirrors of the lens, and mainly just hold stuff. It's the part of the camera that you hold, and its job is just really to be there to contain stuff and make a shape that makes sense to take pictures and contain the components. Lenses work because light bounces off of other objects, and each object absorbs different colored light waves, so whatever is missing from the air in that direction is what the camera knows to fill in as the color of that object. The amount of light, or how badly the film is burned, is how shading in pictures come out realistically. This can also be affected by the aperture, or size of the hole that lets light through the lens. The chemicals inside the film go to work preserving this burned out image so that it may be developed later on. What are these chemicals? I don't hear you cry out because you taught us this and are a chemistry teacher. I'll tell you anyways. The film is primarily made of emulsion, and the lens directs light into this to change the silver halides in the film. Based on how much light touches this silver, it changes to varying degrees, allowing for the picture to be painted. This about sums up how the camera itself works and gets film reader for development. Because that's the next section. Section 4. Development. Now on to Section 4, Development of the Film Purpose. What does each chemical do? Why do the steps in that order? How come it's so complicated? I don't know, but I'm going to find out. The first step is to have a darkroom, or a smaller void of light special container like the ones we use. Make sure the film has a spot with zero light, save red or green tones in a darkroom that won't affect the film. Any bright or white light would set off the silver halides I mentioned before, making the photographs useless. Next, you need to put the film to a series of chemicals to create negatives, or inversely colored versions of your pictures. In a darkroom, pictures are simply dipped in these chemicals, while in the small container we mentioned, you have to swish it around like a madman for a while. Now, before you dip the picture in any chemicals, you need to soak it in water of 21 degrees Celsius in order to have it be the right temperature for the developer. The first of these chemicals is called the developer, named for the process of, developing photographs. This allows for the partially formed silver halides to turn into a more permanent silver that maintains the picture, though too much developer can cause these crystals to form too large, ruining the picture and turning everything black. That's why to stop this process, you need to dip or shake the film with stop bath at 21 degrees Celsius next, which ends this enlarging silver process. It allows for the picture to come out just right in lighting when done correctly, so that nothing is too light or too dark. Because of it ending the process, this needs to be done immediately after. Don't use water after the developer, that's wrong. Don't take a break after or during the end of the developer, that's also wrong. Just add the stop bath for 2 minutes. Jeez. After the stop bath, quickly rinse out the container or picture twice with water for 15 seconds each time and move on to the next chemical, the fixer. Before you ask, yes, this also needs to be at 21 degrees Celsius. The fixer rids any of the silver halides that did not react with light enough, allowing for the dark parts of the picture to develop properly later on. Be careful with the disposal of this fluid, as it is extremely dangerous. I will refer to this multiple times because it is very important. Do not ingest this under any circumstance. If in the container, wash this out thoroughly with a fill and dump where you fill it, agitate it, and dump it 10 times. Next comes the PermaWash, a solution designed to help wash. PermaWash. You then wriggle your hands around like a prepubescent worm for 30 more 15-second rinse and dumps, or just put it in water in a darkroom. Seems easier in a darkroom. Finally, you gently swish your photo in PhotoFlow, copyrighted solution, which allows your picture to come out with no creases, smudges, or watermarks. By the end of the procedure, your pictures will be positives, and after drying for a day, they will look beautiful, so long as you follow the not at all complicated, super simple process listed above. Easiest thing ever. Can confirm that. Here we go. It's your boy Little Stoach, here to drop his hit signal. Chemistry. Chemistry, we got a lot of chemistry. Gotta get into photography. Gotta get the grade or my parents won't love me. Need that A, not that B, C, or D. Chemistry, we got a lot of chemistry. Gotta get into photography. Gotta get the grade or my parents won't love me. Need that A, not that B, C, D, or F. F is for photo, the photography. I am the best, nothing can even stop me developing photos like it's an ocean, a potion for magic in motion. I move like a wizard and use chemicals. My thirst for developing is insatiable. When I start, I can't stop. I hop to the front, shake the dark room back forth. We are here until lunch. Chemistry, we got a lot of chemistry. Gotta get into photography. Gotta get the grade or my parents won't love me. I need that A, not that B, C, or D. What comes first? Hey, it's the developer. It solidifies halides. Ooh, how incredible. But it won't stop until stopped by an acid. The stop bath comes in and it begins to kick in. The stop bath's job is to end its predecessor. The developer elsewise would overdeveloper. Grade the picture and still a fixture that would stay forever intact throughout any mixture. Chemistry, we got a lot of chemistry. Gotta get into photography. Gotta get the grade or my parents won't love me. Need that A, not that B, C, or D. The stop bath is over, yet we still don't wash. My rhymes are as slick as my buddy Akash. Next comes the fixer, instilling that mixture. Keep the image down on the ground as the film spins around. Fixer is done, make sure you timed it right. You'll never get a second chance, so we only got tonight. Do a couple wash and dumps and then the rest is easy. You'll never have to break sweat if you listen to this melody. Chemistry, we got a lot of chemistry. Gotta get into photography. Gotta get the grade or my parents won't love me. Need that A, not that B, C, or D. But hey, water doesn't always work. We gotta get something strong if you know what it's worth. It's called perma-wash and it's kind of soap. If you add this now, you'll get that fixer off like nope. After the powerful chemicals, we gotta wash again. 30 wholesome washing dumps ought to get that settled in. The final step is here, and now it's time to finish this. A little photo flow to finish gets the image nice and slick. And we mix it around. Take it out of the darkroom, hang it up to dry. And boy, there's nothing left to do. Section 5. Return of the development process. This time, with science and big words. We all remember the heating part with water before the chemicals, yes? What if I told you the reason they all needed to be at 21 degrees Celsius was so that the developer could undergo its chemical reaction properly? But, oh Ryan, my dear prince, knower of the great chemistry, what is this chemical reaction? Remember the silver halides mentioned before? These are most commonly in the form of silver iodide, silver bromide, and silver chloride. The significance of this is that these chemicals are easy to break apart in the reaction, kind of like speed dating, but not really, but maybe in a metaphorical sense. Anyways, the two 8GBr Cl or IO molecules turn into a separate two molecules of silver, referred to sometimes as black silver, and a now invisible molecule of 2-bromine, iodine, or chlorine. Silver halides that have been broken down into pure silver by light from the other components are the only ones that can be affected by the developer, which contains metal, metol, phenidone, dimazone, and hydroquinone, all assisting in forming this blackened silver. After the developer has taken effect, making the film visible black and white, the stop bath is added. Where the developer was basic, the only point of the stop bath is to be acidic, neutralizing the developer and stopping its reaction, which can ruin the picture when it's gone too far. We know that the fixer makes the film permanent and allows for it not to be ruined when exposed to light. How does it do that? Magic? It feels that way sometimes. This project is pretty whack. This is because of two agents, sodium thiosulfate and ammonium thiosulfate. These two act as a protective barrier, protecting the once-weak film with their strong chemical muscles. I'm not even going to try to say this equation out loud with the letters. Just know that the silver reacts with the thiosulfates and exchanges the extra bromine or iodine or chlorine. It goes from silver chloride and thiosulfate to sodium chloride and a silver thiosulfate compound, for example. None of the solutions or mixtures used in this lab are resistant to water. That means that against the ultimate unstoppable force that is water, they are nothing. This is the purpose of all the tedious, life-questioning wash and dumps. They clean out these powerful chemicals with nothing but tap water. Ha! The perma-wash is an ammonium sulfite and sodium sulfite mixture, two chemicals that assist in washing both the film and the container very effectively. These two chemicals are powerful cleaners because of their 100% distinctive properties.
The photo flow used at the end is made of water, propylene glycol, water, and prepared octophenoxy. Because it is the last step, it does not merge with the other chemicals in a reaction. It simply fuses with the film partially, and whatever is left over gets eventually washed out. By the cleansing power of water. Water outlasts all. I will not fear. Fear is the mind killer, the death of all deaths. I shall let my fear wash over me, and when it is gone, only water will remain. It washed. Objective: to figure out how photos and film are developed. Mission log, March 2018. Materials: the camera film, the portable darkroom, 4 beakers, a hot plate, an ice bath, labels, the developer, the stop bath, the fixer, water, the permawash, the photo flow. Observations. The only observation that changes is the one at the end, which we will come to shortly. However, we can note on small observations that happened along the way. Hold on a second. All these liquids, these chemicals, they're all clear? All of them? Well, colored me surprise. When you get down to it, there really is only one observation: the amount of pictures you got and the appearance of the film. There's not a lot to say for my group. Nearly the entire thing was clear. We had 4 pictures that you could see with the naked eye, all of which were very faded. Everything else was completely invisible or just not there. Nothing else seemed to be wrong with the film except for the lack of pictures in black. Conclusion. In conclusion, my group was bad. I only got the chemicals and put them there ready for use. I didn't have an important job. It wasn't my fault. I found out that photos can be developed using this method. It does work. What I learned, however, is that you need to be incredibly precise in the manner in which you do it, or you start to lose pictures from your film like my group did. Honestly, though, 4 pictures out of 24? Only 1/6? How does something like that happen? Josh! Sean! Anyways, the data and procedure showed us that, like I said, this method of development works. The objective has been completed, and we now know that this is how pictures are developed, even if we aren't very good at it. There are no unknowns that we needed to find, nor was there any data or calculations involved. Overall, this lab taught us about the core parts of photography development, and we now know that chemical reactions happen in every circumstance in every day, whether we know it or not. This lab is extremely complicated at a molecular level, but to us it just seems like a bunch of swirling liquids in a box. It truly goes to show, don't judge a book by its cover.
Now, considering that this section and Section 5 are the 2 hardest, most scientific sections, it is only appropriate that I will be referencing many of the statements I made in that part. Hold on to your seatbelts, because this is going to be one doozy of a section. Let's follow the same order we did in Section 5, as that is the only logical way to go. It's simple enough. We'll do the stages in the same order as the procedure, explain the chemicals in each solution, and then how they contributed to the process and science we discussed. The first part, the developer, pH of pure base 14. What does it contain? Metal bisulfate, hydroquinone, sodium carbonate, and sodium sulfite. The sodium carbonate and sodium sulfite are what transform the silver halides into pure black silver, which makes this the developer in the first place. The metal bisulfate and hydroquinone join together to form metal with an O. Why is there an O? Why not name it something else? Anyways, this assists in the same process as the sodium and polyatomic ions. They both help to bring out certain tones and variations of black to make the picture have lighting in different ways. The next part, the stop bath. What does it contain? What? Oh wait, it's only acetic acid. Pure acid for neutralization that doesn't even really affect the picture except for stopping the developer. Less cool than developer, I'd say, but still about a 6 out of 10. After the stop bath comes the fixer. The fixer is made of 2 separate solutions, Solution A and Solution B. Solution A contains ammonium sulfite, sodium bisulfite, ammonium thiosulfate, sodium acetate, and water. And Solution B contains sulfuric acid, aluminum sulfate, and water. Solution A's sodium acetate and ammonium thiosulfate are both very important. They are what sticks the black silver to the emulsion in the film, making the image stay. The ammonium sulfite and sodium bisulfite assist in making the layer above the silver highlights due to their chemical binding properties, allowing for the image to stay even more. Solution B's sulfuric acid and aluminum sulfate also help in this process, and are made acidic in order to combat any leftover developer. The fixer does truly fix the photographs, right to the film. The permawash is the primary cleaning agent after water, meaning that all of its chemicals share the same purpose, to act as a sort of cleaning soap, erasing any trace of the chemicals that came before them. Many soaps contain polar molecules in the chemicals that will take any particles that aren't or shouldn't be there, though it only works on liquids due to the fixture sticking to the film. The chemicals that do this in the permawash are ammonium sulfite, sodium sulfite. Lastly comes the PhotoFlow, which consists of pitert octophenoxy polyethylethyl alcohol, propylene glycol, and water. We know that the PhotoFlow's main job is to finish the job by providing help in protecting the film, and this is exactly what it does. The pitert octophenoxy polyethylethyl alcohol does exactly this. It's completely neutral and acts as an agent to bond with the film to make it stronger, less susceptible to light, and less susceptible to damage. It's essentially a layer. Each and every chemical does something. Balance out the pH, allow for a balanced chemical equation, bond to the film, develop the picture. None of them are just there to be there. It's actually quite impressive how they got this down to a science. It's pretty evident that the most convenient way this is going to go for both of us if I just say the items, the composition, and the chemical names, and I put the chemical formula on the screen. So, for my first picture, the first item is a sign. It consists of a post, which is made of carbon steel, and the top part, which is made of aluminum and plastic adhesive. The post is made of carbon and steel, and the aluminum and plastic adhesive are made of aluminum and a chemical called polyvinyl chloride. The car consists of the frame, which has aluminum, white paint, and steel, the tires, which have aluminum and rubber, windows, which have glass and plastic lights, polycarbonate plastic, and copper wire. The aluminum is aluminum, the white paint is titanium dioxide, the steel is steel, the aluminum is aluminum, the rubber is something called isoprene. The windows have the glass, which is silicates, and the plastic, which is polycarbonate. For the lights, it's polycarbonate and copper. The street consists of concrete, asphalt, and yellow paint. These are made by concrete and asphalt, which are just the names of the chemicals, and a paint chemical named Orange Yellow S. For the jacket, it's made of cotton and zinc, which is cotton, gossypium, and zinc. Allen consists of skin, hands, hair, and eyes that we can see, which is made not primarily, but entirely of keratin and collagen fibers. The building is made of concrete, wood, and drywall, which is concrete, cellulose lignin, and gypsum. The trees, which have no leaves on them, are made of cellulose and wood fibers, which is made of cellulose and cellulose lignin respectively. The window is made of glass and plastic, silicates, and polycarbonate. The wall is concrete, wood, drywall, which is made of concrete, cellulose lignin, gypsum. There's a few cars in there, which consist of aluminum and steel for the frame, aluminum and rubber for the tires, glass and plastic for the windows, polycarbonate plastic and copper wire for the lights, which are made of aluminum and steel for the frame, aluminum and isoprene for the tires, silicates and polycarbonate for the glass and plastic, and then polycarbonate and copper for the lights. The shopping cart is made of aluminum, plastic, and steel, which is just aluminum, polycarbonate, and steel. The jacket is made of cotton and zinc, which is gossypium and zinc. The jeans have denim, copper, and zinc in them, and denim consists of cotton and blue dye, while zinc is made of copper and zinc. The shoes have a sole and a body. The sole consists of rubber and plastic, which is isoprene and polycarbonate, and the body consists of cloth, plastic, and acrylic. Now, cloth red 2R is a specific type of cloth, but if you remove the red dye, it becomes cloth 2R, which is what I am showing here. Then there's also polycarbonate and polymethyl, which is acrylic. Josh is consisting of the same things as Alan, just keratin and collagen fibers between all four of his different physical depictions. The lights contain glass, copper, a battery, and plastic, which are silicates, copper, zinc and iron, and polycarbonate respectively. The house is a little large. It has a ceiling, which is ceramic, a window, which is glass, wood, and plastic, walls, which are made of drywall and wood, columns, which are plastic and wood, and a door, which is just wood. The ceramic is made of something called kaolin. Windows are made of silicates, cellulose lignin, and polycarbonate. The drywall is gypsum. The wood is cellulose lignin. The columns, plastic and wood, are polycarbonate and cellulose lignin, and the door is just cellulose lignin. The road is made of concrete, asphalt, and yellow paint, which we've all seen before. The sign is exactly the same as the last sign we saw, just steel, aluminum, and polyvinyl chloride. The telephone post is wood, which is cellulose lignin, iron, which is iron, and it consists of wires, which have a rubber coating and are made of copper, so copper and isoprene. The snow is just water, which is dihydrogen monoxide. The tree is cellulose, which is cellulose pulp, and wood fibers, which is cellulose lignin, slightly different. The streetlight has glass, copper, a battery, plastic, and steel, which are silicates, copper, and then copper for the battery, iron and zinc for the battery, and polycarbonate for the plastic, and steel for the steel. The wall is made of concrete and brick in the back there, which don't have chemical names. They're just concrete and bricks because they're compounds. Well, mixtures, not compounds. Alright, so in this picture we have my dog Chase, who may or may not be... Actually, let's be honest, he is the cutest dog in the world. He has skin, fur, and eyes that we can see, which are, much like a human, just keratin and collagen fibers. The fur is very similar to hair. His bowl is in the picture, which is plastic polycarbonate. His ball is in the picture, which is cotton and plastic, so gossypium and polycarbonate. The couch is made of linen, wood and cotton, which is cellulose lignin, because linen is also made of that. Wood is also cellulose lignin, as we know, and gossypium is cotton. The cage is made of aluminum, steel, and plastic, which are just aluminum and steel, and then polycarbonate once more. The door is wood, plastic, glass, and copper, so cellulose lignin, polycarbonate, silicates, and copper. The carpet is made of nylon and wool, and this particular nylon is a type of nylon named Nylon 66, and wool is mainly comprised of keratin, and entirely comprised of keratin when you bring it down to its core components. There are pictures in the background which are just paper, wood, and glass, so cellulose pulp, cellulose lignin, and silicates. The desk back there is made of just wood and steel, cellulose lignin, and steel. My first easy picture, the object on the bottom there is a candle, which is wax, cotton, and aluminum. Wax is something called hentriacontine. Cotton is gossypium, as we know, and aluminum is just aluminum. The rock is an igneous rock, and it is made of silicon and oxygen. The paints on it are white, but even the non-white ones are made of titanium dioxide in this case. The toy boat is just made of wood and paper, so cellulose lignin and cellulose pulp. And the bench is wood and acrylic, so cellulose lignin and polymethyl. Another easy picture, you have the countertop in there, which is marble, and marble consists of calcium and carbonate, so calcium carbonate is the compound. There's the small lamp right there, which is plastic, aluminum, and copper for the outline, which is polycarbonate, aluminum, and copper. The ladle is just a plastic ladle, which is polycarbonate, and the wipe container is plastic and paper, so polycarbonate and cellulose pulp. My last easy picture is it has the carpet right there centering around the whole thing, which is Nylon 66 again, and keratin, which is wool. The shoes are similar to the shoes we saw before, which is just cloth, plastic, acrylic, rubber, and plastic, isoprene, cloth thread 2R, nothing we haven't seen before, polymethyl for the acrylic. The ball is cotton and plastic once again, so it's the same ball as before, gossypium and polycarbonate. The frisbee is rubber and plastic, which is isoprene and polycarbonate. For my last but not least picture, it is my back room, which has the closet doors, wood, plastic, and copper, cellulose lignin, polycarbonate, and copper. The windows, which are made of glass, plastic, and wood, silicates, polycarbonate, cellulose lignin. The couches have linen, wood, cotton, and these specific couches do have a dye on them, which is cellulose lignin for the linen, cellulose lignin for the wood, gossypium for the cotton, and then indigo dye, which is a specific type of dye that we saw with the denim before. The pillows are linen, which is cellulose lignin, and cotton, which is gossypium. The carpet is nylon once again, so nylon 66 and keratin wool. The walls are wood and drywall, so cellulose, lignin, and gypsum. And the lamp is plastic, which is polycarbonate, paper, cellulose pulp, aluminum, which is aluminum, copper, which is copper, and glass, which we know to be silicates. These are my 8 pictures. I hope you enjoyed. Like, comment, subscribe. There'll be more content coming soon, I promise. Join the fan base. As opposed to a review, I'd like to look at this as more of a highlight reel. Go back over the past 30 minutes for you, the countless hours for me, and just remember all the best and worst parts of this project. We met in Section 1 and learned all about who made photography in Section 2, why they did, and the philosophy behind it. In Section 3, we took a look at cameras, which we needed to do to move forward. Section 4 was simple enough, why we do each step in the development, and in Section 5 we went more in depth by naming the exact chemical equations and processes by which we develop photos. Section 6 was the write-up, in which we confirmed that this development process in science was right, proving our hypothesis. Section 7 was the other side to Section 5, naming the chemicals and explaining all of their properties. Lastly, Section 8 was a painstakingly long monologue of picture-y goodness. The real question is, what's the point? No, not of living, the point of the project. And I think it's this. This project encapsulates all of the basic principles of chemistry, from the first elements we learned about to the charge rule, which is used in balancing equations. We identified some polyatomic ions and even wrote the chemical names for any chemicals we could identify. We did balance equations, found products. This project proved that there isn't anything that we can't do. I believe that's the point. We managed to do it all. Made a real accomplishment and a real result. And there's something special and cool about that. Thanks for taking this ride with me. Good night. Goodbye. Okay guys, before I leave, I almost forgot, I still need to do my glossary. So, the first one is emulsion, and that's a gel-like film layer that protects the physical film section that contains the picture. There's silver halides, a compound of silver and either chlorine, bromine, or iodine, which has the property of being turned to black when exposed to the sun and dropping into pure silver. Agitation, a method of shaking or mixing the dark room with the chemicals inside, which typically involves a methodical wrist movement in circular and up and down motions. Titration, a neutralization between bases and acids that ends any reactions going on with either, making a new compound as opposed to the 2 other chemicals. Wash and dumps, a wash method where you fill the portable darkroom and agitate it for 15 seconds while it was filled with only water, often done consecutively. Extra credit, something Mrs. Smith gives to Ryan Westervelt because he tried so hard. One last final thing to end my project. Here's a QR code containing all of my references. If you scan it and you are hooked up to a school account, your school email, then you will be able to access the document. It needs to be part of the school domain, and you could do it with any phone app.